So this is going to be our hardest problem here. In fact, this whole field is called stoichiometry, the idea that we can calculate from what we start with, what we'll end up with. So here's one here. This is the hardest one we're going to do this semester, I believe. So the question is, how many grams of water are formed from burning 23.9 grams of C3H8. C3H8 is propane. And if you're grilling outdoors, you're probably using a propane grill, I'm guessing, unless it's charcoal. And how are we going to do something like this? I think we probably want to make a plan. And just like before, I would say right underneath the chemical equation, we're going to write moles. And the line below, we're going to write grams. So we are starting with 23.9 grams of propane. So 23.9 grams of propane. So that's C3H8. That's Hank Hill's favorite hydrocarbon, by the way. And what do we want to do? We want to get up to moles of propane. So we want to go up around, okay, and we want to go to water. So we get to go all the way over here. So we're on the mole line. So how many moles of water? And then we want to go down to the promised land. How many grams of, not propane, right? How many grams of water do we have right here? So how are we going to do that? Well, of course, it would be absolutely wonderful if we could just go directly from here to here, but I don't know of any way to do it. So all I know is you got to go up and over and down. And here's how you do it. So the conversion factors we need to go up, we need the molar mass. So that's the mass of all the atoms of propane. And then we go from moles to moles. When we go from moles to moles, we use the coefficients in our balanced chemical equation. So that's where we get to point our fingers again, right? So our fingers, if we go ahead and we point them, if I can find my finger again. So we've got one of those, and it makes 4 of those. So we would have 1 mole to 4 moles when we go ahead and do that part. And finally, we've got to go from moles to grams. Well, we need the molar mass. That's the weight of all the atoms. And this time we need it for H2O. So we can do those. And let's go ahead and try it. So C3H8 is made of 3 C's and 8 H's and C's. If you use your periodic table an awful lot, you probably remember 1201. And hydrogen is 1.01. And if we add that up, we get a smooth 44.11. So that's how many grams there are in a mole of C3H8. And if we go ahead and we take our fingers again, so we got one of those. Keep our finger there, and we got 4 of those. So we need to write 1 mole of C3H8 is equivalent to, will make 4 moles of water. It's really just a ratio. So even though we don't have 1 mole, it's still in that 1 to 4 ratio. And finally, we can go ahead and we can take the water. And the water, of course, is made of 2 H's and 1 O. And notice in the balanced chemical equations there are 4 waters, but we don't multiply by 4 because step 2 actually takes care of that 4. If we do it by 4 and do it by 4, we've done it twice. That's 1 time more than we need. So hydrogen is 1.01. Oxygen is 16.00, and that is 18.02 grams of water is equal to a mole of water. So I think we are now ready. So I just went ahead and sneakily pushed it up the screen, but now I am ready. Are you ready? So we're going to go ahead and start with our 23.9 grams of C3H8. And boom, we're going to multiply this sucker 3 times. So we're going to go from grams to moles. So, okay, so we need a molar mass of C3H8. So 44.01 grams is equal to a mole. So which way around do we write it? So, gosh, we got grams to cancel. So we need grams on the bottom. And let's see, not 43, but 44.11 grams. C3H8, we really want to write these units in, otherwise we're going to get into trouble later, and that's 1 mole of C3H8. So that is step 1. Check. These problems, by the way, when I was in high school, I thought, gosh, my high school chemistry teacher must be an absolute genius for getting stuff like this. And what you find out is the more you do, the easier it gets. So step 2 is we need the mole to mole ratios, right? The coefficients, perfect. So we got 1 mole of propane gives you 4 moles of water. We need the propane to cancel out, so we need the 1 mole of propane to go on the bottom. That gives us the 4 moles of water on the top. That will kind of survive this step. So if we cancel, that's gone. And the moles of propane, we just canceled out there. And the very last step, so that was step 2, is to change the moles of water into grams of water, and we use the molar mass for that. So we calculated the molar mass. We know there's 18.02 grams in a mole. We put the mole on the bottom because it's got to cancel with the mole on the top, right? So we kind of lay that there to be canceled out straight away. And the 18.02 grams goes right there. And that's what we're left with. So at the end of the day, right, we're left with grams of water. And I'm going to punch that in my calculator. And when I round to 3 significant figures, I get 39.1 units are grams of water. So we did that calculation. It took us a little while, but there we are with the answer.